Now one more problem I am taking, which is based upon the independent theorem. If A and B are two independent events, meaning of independent events is the occurrence or non-occurrence of one is not affected by other. If A and B are two independent events, then prove that probability of A union B. In the language of words, we can say probability of happening at least one of the A or B. Probability of A union B must be equal to 1 minus probability of A naught into probability of B naught. It is required to prove under the given condition that A and B are independent events. We know that probability of A union B by the addition theorem, PA plus PB minus probability of A intersection B. So we can say probability of A union B is equals to PA plus PB minus probability of A intersection B can be replaced by probability of A into probability of B, because this is especially for the independent events, and we know that the result probability of A intersection B is PA into PB. Now PA is as it is if probability of B is taken common. Then if probability of B is common, then we will get it is 1 minus probability of A. If 1 minus probability of A, that is 1 minus happening, is what? Probability of not happening. So in place of 1 minus probability of A, we can write probability of not happening of A, probability of A bar, probability of A naught into probability of B and probability of B, A as it is. Now in place of probability of A, we can write 1 minus probability of A naught. 1 minus probability of A naught plus probability of B into probability of A bar. Then probability of A bar is common, minus probability of A bar is common, then it left with 1 minus probability of B. It is 1 minus probability of B, which can be written as probability of B naught, because not happening is 1 minus of happening. So this become 1 minus P of A naught into probability of B naught. So this was the required result which we want to show, that the probability of A union B is 1 minus probability of A naught into probability of B naught as shown you in this example.